Hello, welcome back. In this video, we're going to demonstrate delegation in a very simple way. What I've got here is a simple parts order screen, and I brought back the part class from Unit 1. And we're going to use this class and some other classes with it to kind of develop our, for the course, an entire manufacturing parts ordering asset management kind of application, so you can see how all the pieces fit together. And this is the first step of that. It's just a simple ordering screen. We're not going to allow the user to select a part. We're only going to order one part at a time, but it does explore this principle of delegation. So I've got two labels. I've got a static label, part order, and then I've got a button labeled order 1, and then I've got a label here. And my properties and methods are bound in files owner. The message is this label, and then order part, the action, IB action method order part, is bound to this order 1 button, touch up inside event. So there's our target action. So now let's look at this delegation thing. Here's my part class, and I've made some alterations to it. I have a delegate here, a protocol called part delegate, and I've got two required methods. The first is quantity low, and it has a parameter of the quantity of that part, and then I have quantity 0. And these will be called by the part class when the quantity reaches certain points. A reorder level in the case of quantity low, and 0 in the case of quantity 0. Now, that property, or that protocol, I've made a property out of. And here's my property declaration for my delegate. Non-atomic, unsafe, unretained, ID, and then here in angle brackets is the name of my part delegate, and then this property is referred to as delegate within this class. So I have a property of delegate. And then I have the part name as and then a string. I have the quantity as an int, and I have the reorder level as an int. I have an overridden init method here called init with name, quantity, and reorder level that will initialize a part. And then I have a method here called order quantity, and this will order however many parts we want it to order. So let's look at the implementation. Remember, I have this delegate property. Now, part doesn't know who or what its delegate is going to be, and that's very important here because of dynamic binding. Part won't know what its delegate is until runtime. So I've synthesized the delegate. I've also synthesized our part name, quantity, and reorder level. And here's my init with name, quantity, and reorder level. And this is very simple. I just take those three parameters that I pass into this initializer. I call through to super, very important. We've talked about that before. And then I'm checking to see if self exists. If self is not nil, it shouldn't be because I've called up through to super. So if self is not nil, then I set the part name, quantity, and reorder level properties depending on the values passed into the init with name, quantity, and reorder level method. And then I return myself. And this is why we have this ID, so that I can return self. Now here's order quantity. First of all, I subtract this parameter, quantity, from my self.quantity. And then I check. I want to know if self.quantity is less than the reorder level, or equal to the reorder level. And if it is, I call quantity low with that quantity on my delegate. Now, again, part doesn't know what its delegate class is. It's got the name of the method, but it doesn't have the implementation of the method. Neither does the protocol. Only the delegate class will have the implementation of the method. Again, if quantity is equal to 0, then I call quantity 0 on my delegate. Okay, so all of that is good. Let's look at the view controller. Now, the view controller is the delegate for the part class. How do we know that? Well, first of all, we have adopted the protocol. We have adopted the part delegate protocol. Then I have a property, which is a part, called widget, and I have an outlet property for my message label. And then I have an action, order part, and this is the button click handler. So now let's look at what happens in our view controller. Remember that I've adopted that protocol. If a widget doesn't exist, if my part does not exist, my part class called widget, I need to make it. So I lazily instantiate it. So I say, if not widget, widget is part alloc, and then in it with a name of widget, a quantity of 5, and a reorder level of 3. So when my delegate method is called back into part class, it's going to compare its quantity of that part to the reorder level and fire off that protocol method back to my view controller when that reorder level is hit. Likewise, when the quantity hits 0, it's going to fire another one off. Here's my order part handler. I'm going to order one part each time I click that button. And I'm going to set the message text to be equal to remaining and then a number, which comes from self.widget.quantity, the quantity property of my part. In view.did_load, here's that bit of magic that sets this class as the delegate of the part class. Self.widget.delegate is equal to self. I could also have done this. Self.widget. Sorry about that. Widget set delegate self. And that says the same thing. Then I set my message to the quantity in view.did_load. And initially, that quantity is going to be 5. So rather than this label just saying label, it's going to say quantity 5. Or whatever it says. Remaining 5. Pragmas are a way to group methods in your classes. This pragma mark hyphen, actually all that does is it gives in Xcode a way to group our methods under a heading. I have a part delegate heading, and here are my part delegate methods and pieces. So that's all pragma does, and it's useful for grouping some methods together. So I have a method here called displayAlert, and this is a private method, and all this does is just a little helper method to make a UI alert view when that we can pass a string into that will be displayed. So my title is alert, my message is whatever message we pass in here. Delegate's nil, it could have been self, but we can use nil here because we're really not doing anything with this delegate. The cancel button title is okay, and then there are no other buttons, so other button titles is equal to nil. And then I show my alert by sending the show message to alert. Now, that is it for this view controller. But this view controller is the parts delegate. So I have to remember in the part, my protocol declares 2 required methods. So as soon as I adopt that protocol, I have to implement those 2 methods. So here are my implementations. When this class gets the quantity low message from the part class, it's going to do this. It's going to call displayAlert with the message reorder part exclamation point and then the number remain. And the number we get from self.widget.quantity. And likewise, when quantity is 0, we're going to call displayAlert with the message no parts remain. So now let's watch what happens. So now we have this remaining 5. There are 5 widgets in our pool of parts. If we order one, it just says remaining 4. Now if we order another one, it's going to reach the reorder level. So we should get an alert. And we do. That is from the delegation from part up to our view controller. Now remember, part doesn't know what its delegate is. It's the delegator class. It has no idea what the delegate is. But the delegate knows who it is. It's the view controller. So we're getting an alert, reorder part, 3 remain. So we'll click OK. And then this is a reminder to the user that we're getting low on parts. We order another one, reorder part, 2 remain. Again, we got the delegate message. All right. What happens when we get to 0? There's 1. Now, If we get to 0, we're going to get both messages because we're less than the reorder level and we're also at 0. So watch what happens here. Both messages happened. When we dismiss this alert, here we have no parts remain. It happened second. We dismiss this alert comes back, reorder part 0 remain. In a manufacturing or an asset system, we might also be able to order parts if there are no parts in the pool. So let's order one again. Now we know exactly how many parts are in the pool, 0 really, but here we haven't done that checking. We should have said less than or equal to 0. But it does say reorder part -1 remain. And we can do this all day. But because we are below the reorder threshold, we're going to continue to get this method. We are less than 3. Less than or equal to 3, right? The reorder level that we stipulated when we initialized our part with a quantity of 3 and a reorder level of 5. All right, now we can break this in a lot of different ways. The view controller is adopting the delegate protocol. So let's see what happens if the view controller does not adopt the protocol. Let's get rid of that. And now we'll rerun our application. And we got a little runtime bug. So let's order one. Okay. All right, it still works, but we have a runtime. It still all works, but now we have a semantic issue of sending a view controller constant strong parameter of incompatible type. What are we doing here? We've got a view controller type going back to a delegate, which is defined as an ID type. So this is just telling us we've got a typing problem, but the delegation still remains. So to get rid of that, let's go back to our view controller. To get rid of that, we need to adopt the protocol, and then that type will resolve itself. Now, here's another thing that can happen that is often forgotten. Suppose we forget in view.load to actually do this, setting up the delegate as self. So we'll comment that out, and now we'll run again. Watch what happens now. There are no errors. Now when we order, the delegate method doesn't actually get called. None of them do. Even though we've defined a delegate property, we've adopted the protocol, we have not set the view controller as the delegate of the part. And so this must be done someplace. It can be done in view.load. It could have been done in the the app delegate method, which is init with nibname bundle. It could be done there. It can also be done when we lazily instantiate the widget. We could have done it right here and said widget.delegate equals self. But regardless of where we do this, it must be done. Otherwise, the delegation doesn't hook up. Okay, so I hope this explains a little bit more about delegation. We're going to be using delegation many times as we learn to develop applications for iPhone using Objective-C. Thank you very much.